All right, so we're going to go ahead and start doing a 74 stroker. This can be done with a 1600. You could use 85 and a halves. You could use you could use. We're going to use 90 and a halves on it though. So we're going to have a 1904, I think it is. So the first thing you have to do is actually assemble the crankshaft. And we're not going to go through the whole assembly the first time of the crankshaft, but we'll bring you guys back in when we do it the second time. You have to assemble the crankshaft and put it in here and then figure out where to clearance. Now, you can go to a machine shop and you can tell them to clearance the case for you, and you'll avoid a little bit of this work. But then again, some of you guys don't have access to machine shops, and basically that is what this video is going to be about, is making it so that you guys who don't have access to machine shops can see how to clearance your own case a little bit. And it's a little bit of guesswork, but there's a little bit of and it's pretty messy. So when we put this, when we bring you guys back into the video next, you're going to see a lot of machining mess, and then you have to clean every part all over again. So it's a bit of work going that way, but it's worth it when it's done. So I'll talk to you guys a little bit later, and we'll bring you back in on that. Right, so the crankshaft, we went ahead and quickly assembled it. Got it to rotate right, and then what you do is you put it in. And what we do is we put it in and we actually rotate it over, and you can see right where, if you kind of hold the rods in the position where they're supposed to be lined up with the piston like that, you can see right here is where they usually hit. So just a little clearancing right there, and right here too. So you can come around, you kind of come around here, you can kind of see where it kind of can hit right there. If you guys can see that. All you got to do is just clearance right here and right there on this engine. You should always check every engine in case your case has some weird machining spots that are in there. But with these rods, which is nice, it's just, you can, guys make clearance, the original factory rods can be done, but then you have to reweigh them and remeasure them and all that, and make sure that they're within, the spec of each other. Whatever it is from one rod to the next, you have to really spend your time doing that. I mean, if you want to do that, you can, but you can also, but it's easier just to buy these already machine ones. Like I said, they're about $125 or something like that for these, and they're chromoly. So I don't know if that's any stronger than that factory rod. The factory rods are pretty strong. So, but these are where we go. So that's how we do it. I'll show you guys after we're done doing the machine work, and then after that you got to clean up everything again. Your crankshaft, everything's got to be clean again before we reassemble it to make it run. Alright, so those of you guys who are wondering what we had to actually do to the case, it's just a little bit of this right here and a little bit right here. Every once in a while you'll have one where it right at these bolts, it'll be a little bit of clearancing needs there and there on the 74, but most of the time it's just this and that, and again, that's kind of subject to. So you put it in, rotate it, check it, look at these areas, make sure it's not hitting here, and if it's grinding there, just take a little bit off. That's it. But be careful if you're near the case saver. Those are steel, and you don't want to make sparks, so be very careful. So this is what we're doing. We did here, same thing. This side got the here, and here. That's it. Already ready, so we're ready to assemble. But the first time when we put it together to check everything, we did check the rods. There's always some little bit of machining off on these, and let's see if I've got one here that we did. So this cap, there was like a little bit of a weird edge along here, so we sanded that off, and then just carefully, and then reassembled it and checked them, made sure there's no tight spots. If there's a tight spot, you can turn it around, look at that bearing, look for that little shiner, and if there's a little shiner there, then you know that there's an issue behind it on the other side. And just check the rods over really carefully, and just clean them up or whatever you need to do to make sure that they turn evenly. Sometimes we've actually sanded a little bit on the bearing, like on the last one we had a little tiny spot right here where the tang was kind of tight. It was easiest just to sand a little bit right in their bearing, and we went down to like 1200 grit and got rid of that. Again, that's up to you how you deal with that. So let's move on to the next thing. Again, they're heating up. While they're heating up, I'll tell you about these. Again, these plugs, take them out, clean them, clean everything out, and make sure they get red Loctite on them and put them back in. That's what we always do. Otherwise, those plugs can come out and blow up your whole engine. Remember, the bearings have already been the port matched. They're see right here. Here's your little grind mark. How we do that. If you watch the other engine build videos, we always port match the bearings. It's set in the right place for the holes, and we're ready to put our gears on in a minute. So as you guys who are new to the videos, we always put the bearing in and then check to make sure that we use a little bit of paint out here. Check and make sure that that port matches the groove, because they never do match. And then put that little machine mark that we have in this right here, that little machining. We machine that with a little grinder, and just make sure that the oil can get its way in there and use all of that hole, because it covers up about half that hole. Again, we do use a hot plate. You can use, guys use boiling oil. I've seen guys use a little propane torch, but remember, not get that one too hot, because you can melt that sucker. Still a little close. You put your gear on. Oh, that one slid on easy. Sometimes you get unlucky and the gear actually doesn't go on. You have to press it back off because you didn't wait long enough. Right, then the spacer, we got that on. And you got to do this kind of quickly, so sometimes I don't get it all in the video. Your good old brass gear slides on next again. And then the snap ring, and we'll bring you back in after we get that on. Alright, so we need it all to be done before the gears cool. Now we're going to let the gears cool. Snap ring is on. You see it right there. Noise alert. A little bit of air. Slow it down. That's what we do. We can just wait, whatever, come back to it. We'll take them out. Go back. Doesn't matter. On the Shattuck pump gears, we've had 2 engines actually have this shaft spin, this thing spin on here. We haven't tack welded this one yet, but we always tack weld the gear on very carefully and then make sure that it's perfectly smooth on this end and there's nothing sticking, no slag or anything. So we always do that too. Now, since we had 2 engines, 2 of them, that this gear was spinning, couldn't figure out why the oil pressure wasn't coming up. It would work at idle, and then as soon as you gave it any RPMs, it wouldn't go up. So it was because this was spinning. And Shattuck's a good company. They've been making oil pumps for years. Bearing, make sure it's the right direction. Slinger and key. You guys new to the channel, you can always watch the bulletproof engine build, and that one will show you again how to do some of this stuff. In fact, there's also a 1600 one. There's going to be some others coming up. So make sure you push the subscribe button if you're new, and check out some of the other stuff we're doing, rust repair and all kinds of things. Let's see those comments roll in as well. Roll them in. Bring them on. So you guys that are new, also these rods do not have the little bump on them. Like here's a stock rod right here, and it has this little marker. These ones don't have that, so you have to go by which way these guys are, and they go, the little tangs here go down. So when it goes into the case, they need to be here. So make sure you do it right. That's how we do it. Then if you're using these aftermarket rod caps, they already have numbers usually on them, and make sure the numbers match. If you just put any rod cap on, obviously you're gonna mess up big time. And both tangs obviously go together on the same side and they face downward. We also oil the threads on here so that you get an accurate torque. I may not have showed that last time. But we also, when you see us get out the little hammer, some guys commented and said, "Hey, what are you getting the hammer out for? You shouldn't hammer your rods." If you don't do that sometimes, whenever you're using a rod bolt instead of a nut, we even do it with all of them, but if you put them together and then tap the sides with a hammer, that helps to seat the rod into the bearing. We do it between torques. We do it right at the end after we've done torqued them, and then check it again, because we've had times where they just didn't seat all the way, and the rod will be turning and it will have a little hard spot in it, and then you tap it and it's fine. So that's the way normally most guys do it. And when we put them together also, we're going to check the run out here, even though we know it's a brand new engine. I usually do it by feel because it's got a pretty wide tolerance, but you need to check your book for that one. Again, assemble, tighten a little bit, turn it, make sure there's no hard spots. Now some guys will say, "Oh, the machine work in those rods are terrible," and blah blah blah. And but listen, we haven't had any problem with them as long as we check them and make sure that they're right, and kind of double check that machine work. We've never had a problem with them. The reason you'll see where we paint markered the numbers on here is because we fitted to make sure each rod works on each journal. And because sometimes you'll put an engine together and one journal is just slightly different, and another rod will fit better on it. So always check them, and then put them on, take them off a few times, and make sure you get everything so it spins correctly. Then, like I say, we just go ahead and put the same rod on that same journal, because then we know it fits on that one right. So they're all on. Of course, they're not upside down. We double checked them. On these, you really better make sure they're right.
Now they're upside down.
Now they're upside down. Now they're right side up. See, if you have them numbered like that, it helps you kind of think to put them in the right direction. The right rod goes right where it is. And then also it helps you, make sure that you knew that rod fit on that journal. So if you tighten it up and something's not right, to look again or whatever. It just helps to kind of reference your thinking. Well, on these particular rods, again, you should always look up your own torque specs. We're going to go ahead and run them up to 30, but we're going to do them to less than that right now first. 30 foot-pounds, and that's what we found for these. But again, that's your deal if you want to look it up. Because they have different specs. Remember, these are not Volkswagen rods, so the stock rods are like 24, and so these are different. They have a different spec, different bolts. The rod bolts are not rod nuts. They're different than the VW ones. So, and that's all because they're clearanced, and these are supposed to be stronger bolts even than some of the others. But who knows? Whether it's better or not, I don't know. But it does work. Really good luck with them. Yeah. So the rod lengths we got on this one were they 5.375? 5
stock length.
Stock length. So I think you can use 5.4s as well. But what happens if you use for this type of build that we're doing, that's with A pistons. With B pistons, it's going to be different. You're going to have to go with a completely different rod length. All right, so we got the cam bearings put in. We test fit the cam. Make sure it's not too tight. Just make sure everything feels right. There are specs for those things if you want to look them in your book. Got our center main put in. One of the things we have always inspected too is we put that rear main in and make sure it's not sloppy or too tight. One of those two. So we've already done that checking. Actually, that's the front main. Sorry. All right. We ready to go in? Oh, lifters. No. Oil. That's what we need. Look at that glob. That's our special mix of oil. STP and Marvel Mystery Oil is what we use. You guys can use whatever you want. You can use motor oil. Works fine, but it all depends on you, what you like. I'm the old STP and oil guy, but Marvel Mystery Oil sounds like a good little assembly lube. We also have the other stuff. We use this stuff here for the cam and stuff. Some of the parts. Don't forget your dowel pins, guys, in the case. And then we can turn these around and carefully let them drop in. You can mark them, mark the opposite of where the dowel pin is if you want on the bearing. Sometimes that helps. And she used a tight one, and I'll tell you what, that front main is like nice and tight. Never been thrust cut either, so really nice to have that in a case. Give it a little tap. After you know everything's in right place, then we rotate it, make sure it didn't get bindy, and then drop the center main cap on the middle. Where'd it go? So we drop that on there, make sure she doesn't wiggle. There's no wiggle there. It's nice and tight. Doesn't have any. It would just wobble if it was not. If you missed a dowel pin, didn't get them lined up. Do with the lifters. Get all the holes all lubed up. You can use whatever you want on that too, but we like to use this for that. Seems like probably where the biggest failures are the cam during break-in. If you're gonna, you know, but it all depends. There's things can happen. This one we're going with these gap lifters. We like the little ones with the big holes in them, the lightweight ones, a little bit better. But these are kind of pricey, but they didn't have any of the other ones in stock. Even though they're new, we still clean them. Always clean everything. And we oil them. Make sure that they spin. If your lifters are tight in there and they don't spin, they're too loose. You know, they're wobbling in there. They're too tight. That'll be an issue. So they should be able to spin nice and easy. That's one of the things that we've always found. That's usually the issue you have. That's why cams go flat most of the time right there. So that's what you need to be watching for. Yeah, we were just talking now, and back years ago, one of these guys walks into the auto parts store, and he goes in the store. This is like quite a while back, and he says, and he goes up to the counter. He says, and he's there at the counter, and he's going, "Estapa, I want some Estapa, Estapa." And the lady's going, "I don't know what you're talking about, Estapa." And then somebody goes, "STP." He goes, "Yeah, STP." So we put the cam in, and this is some of the things we check for. Sometimes this happens. So when you notice a cam jumping up, it wants to jump out of the lobes. So this is probably one of the cam gear. One of these two is not meshed correctly. So that's the type of thing. That's why we always rotate it before you do it. And then so we're gonna find another cam gear for this and try that one. Make sure we got the one that matches that gear. And if not, we got to take that one back off and change them both. But when that cam jumps up like that, when you spin it around, that's when you got the wrong cam gear. So we'll try a different one. We'll bring you guys back in when we find the right one. So we did find the cam gears a little bit not quite right. So we're going to go ahead and change that with another one we got laying around in the vise. Put it on this cam, and we'll bring you guys back in a little bit. Alright, so you guys remember this mark here, straight line, the lobe going the opposite. Mark up here, that lobe going the opposite. So some guys, I want to talk to you real quick about cam gears in the middle of this one. Some guys say, hey, I want to run the straight cut gears. You know, there's the reason they made straight cut gears. Well, the reason they say to do that is, you know, they want to go straight cut is because what that does is there's resistance because these gears are sliding together instead of just running, because there's, you know, because the angle of the gears. But what that does is keep the noise from getting too loud. And also the other thing it does is create less resistance here with the camshaft, and also, you know, it's also because if you have a really large cam, then you can have more resistance in your lobes. So it's to offset some of that stuff. But the disadvantages of going straight cut are the vibration from the gears meshed together, running up all the way through your valve train and causing all kinds of havoc. It's kind of like a supersonic cleaner. You know, if you ever put something in a sonic cleaner, there's all that really vibrating stuff going on, and inside the engine it's extra vibrating. That noise you hear actually creates vibration inside your engine and causes wear to some of your valve train and other things. So, you know, if you don't need it, I don't run it. So I'm not going really big on the cam, so and I'm not racing, so I'm not going to put a straight cut gear set in most of my engines. So again, if I made that clear, a really big cam with a not a straight cut gear, without straight cut, with this kind of gear, a really giant cam will put more stress right here at this bearing, because there's so much resistance there from the gears sliding together that it creates wear right here. So if you have a really big cam, that's when you have to go with the straight cut gears. If and you got, you know, dual high rev springs, you have all the good stuff in there, but then again, you're going to cause engine wear somewhere else by doing that. So yeah, it's just don't stay too big. If you're going to go on the street, there's no reason to go with dual high rev springs. You know, it's just like, you know, and go with the giant cam. There's just no, it doesn't make any sense. Okay, so we wiggle the gear, it should have a little bit of lash like that, and then be in there. So the other one we had no lash. It was just like tight, and that's when you got to take another second look and make sure that they didn't put there's like a +1, a -1. I don't know how they work, but there are different cam gears for different, you know, I don't know, they're different manufactured, different years, whatever. But you can get one that doesn't fit like this and doesn't have that little bit of rattle. All right, so this one here we went ahead and put, remember this one here does not have shuffle pins. Like if you watch the Bulletproof Motor Build, this has the O-rings, so we put all the O-rings on. Okay, and we just went ahead and used the Permatex sealant again. So we have laying around. You can use Permatex sealant, just giving you some guns. Remember, there's always case movement, so you don't want something that gets hard. Some guys use silicone, and that will move, right? So I think that's an okay deal. Some guys want to use that. But the problem with that is sometimes trying to unseal the case, it's kind of difficult to get off. So someday when you go to split the case, especially if you use this stuff right here, you might have a real challenge trying to get it off. Again, get the case split apart. So we don't use that, we use this. It works fine. Another thing I've used before is Yamabond. It's motorcycle case sealant for aluminum cases. That works really well. So however you want to do it, you know, you can, I'm just giving you some ideas so you can figure out some stuff on your own. Sealing our lifters and then oiling them. Put them in the case, make sure they spin both sides. And then this time we're going to use our lifter clips. These right here, they hold the lifters in place so that when you drop your cases together, you don't have a boo-boo and drop your lifters. So sometimes we seal both sides of the case, just because if you have a little bit of voided sealant somewhere, just so you can do that either way. But you may need that if you use silicone, I'm sure. But sometimes it helps. It depends on what you want to do. We're just showing the different ways to do it. So we always assemble and put the oil pump in before we put the case halves together. Especially if you're using a 30mm pump. We found sometimes they actually hit, I think it's right here, right?
Yeah, right there.
This one will hit the bolts or the rivets. And I've seen camshafts like shear the rivets off. If you wonder why that happens, it's usually because the oil pump was not double checked. We have about 80-90 thousandths, so you can actually put a feeler gauge in there if you need to, and make sure that there's plenty of clearance. Yeah, we're just popping the lifter clips in. Those hold the lifters in place. See, like that. One more over here. They just kind of grab the lifters and just kind of keep some spring tension on them so they don't fall out, and double check them, pull them and stuff. Make sure they stay. A little silicone in the cam plug. This is the tricky part. Do you think you will get it the first time, guys? So you guys comment. Make sure you guys comment on the video. Really does help make it easier for other people to find. How quick are you at getting it together? Oh, he did it. He got it down there. It wasn't like the 2007. Those aluminum ones are so tight. Okay, so well, we're going to check our deck height here pretty soon since we get this thing set up and make sure that we chose the right rods. We'll let you know in a little bit if we did or not. And with this one, we were low on hardware, so we decided to get a hardware kit. Those are pretty nice to have if you guys are looking for those. They do have them at AA. That's who gets them and manufactures them. Just as a precaution, put some sealant around these guys here because they don't have O-rings on them. You know, and if you're doing shuffle pin case, something to think about. You definitely want to put sealant around these. We put it around them anyway, just because you never know if that O-ring's going to hold. Maybe it just gets old over time, and then this stuff like never dries. So we put this on here. We always put these ones on first. Put this group of them on there, but we'll torque these ones first. So again, put all your hardware on. This one here, like I said, we're going to new hardware kit. And give it a little tighten down. Those ones are always the ones that pull, so always want to check those ones first. So yeah, we just get them all snug here. Then we're going to torque these ones first.
With assembly lube.
Let's get them a little snug. And we're going to run these two down real quick first to make sure they, yeah, that was okay. That's where you usually have your issues if you're going to make sure they tighten. They don't pull. For once in a while you get those that they just pull out and then issues.
Little spongy.
Then we always check rotation, make sure everything's good. Doesn't feel weird or hard or anything. Feels alright. It's all new stuff. So if you're running 85.5s, we're going to go ahead and check our deck height before we put all this stuff in here because we want to make sure we have our rod length right. Usually, I think if you can go with 5.4s, you're going to be fine. 5.4 rods. We went a little bit shorter rod, and if it's too short, then you'll have a big when it goes all the way to the top, it'll have a big gap at the barrel. So we're just going to give it a shot here and see. But if you're running 85.5s, you probably will need to clearance your pistons. The skirts are a little longer, and that is a whole nother issue that we could. I don't know if we'll put that in a different video. Maybe we could just show you a little bit about how to do it if we have a stock piston laying around. Well, it ended up being all right. We went with the 5.3. What are they? 5. Yeah, so I think they're 5.325 rods instead of the 5.4s, and it ended up being to our benefit because as long as this piston is sticking up above the cylinder, so that means we can shim it up. And what I was worried about is it being too short and being below the top of the cylinder with too much gap, and then we wouldn't be able to use shims. So the 5.325s seem to work okay with the 74 on this engine. Every once in a while you might have one with a different deck height, and this one's been decked a little bit, so that might be, I'm not sure, maybe I don't think they took more than 10 thousandths off of that, and this is sticking up more than 10 thousandths. It's definitely sticking up more than 10 thousandths. So if you want to try and use those rods for your 74, that might work out good for you. The shorter the rod, the less reciprocating weight, right? So they're probably a little bit lighter than the other rods are. So that will give you a little bit better revving RPMs too. So anyway, that's what we're happy about that. So we were worried that this piston would be below the top of the cylinder too much, and if we were too far below it, then we would have more of an issue. So, but it seems like we can do this no problem. What are you going to probably need, but 90,000 shims or so.
We have 30,000 deck height right now.
Couldn't remember the rod length, so I did ask brothers, and I think he said 5.4s, but then I saw these ones. I was like, oh wait, 5.4s, and he says it comes around 90,000 deck height. Well, we ended up with this machining here. So anyway, you could try these rods. If you went with 5.4s, you probably would end up with, let's see, 5.4 would be a little bit higher. You would need like a really, really tall shim on there. You might need 2 shims. So I'd rather have 1 shim than 2. So that's why I went with the shorter rods and hoping it would work out. And it did so far. So one of the things you always do is take your rings off of your new pistons and check the ring gap. And sometimes they're too tight. If they're too tight, what will happen is your engine could seize up. So these ones are actually really pretty tight. So we're taking and sanding them a little bit and opening up the ring gap just a little bit to where we feel that they're within spec. So also stretching the push rods. Where's them? Can't not focusing. We're also stretching the push rods out right now. Stretch them out a little bit before you put the stuff on. So yeah, then you stretch them out, put these on, push rod tube seals on, get them all on there. All the same. I just bend them one way, like this, and bend them the other way, flip it around. Do that a couple times. Stretch them out. Put your push rod tube seals on, and you're done. So we take the ring, and then we file the gaps right here, like that. You don't want to file the edge of the ring, of course. You don't file this part. You file in here where the gap is. Then we check it again, put it in there. You know, this stuff takes a lot of time. This is all, every motor we build, we do this stuff. Check the gap and make sure it's within the specs that we feel are right. I mean, there's the factory specs, and then, you know, you can look in your book for that, and then.
So this is 16,000, so it's still too tight, so we gotta take a little bit more off.
Yeah, so we have a spec we like. Some other guys have other specs on that, so we'll let you guys look at the book for that. All right, so I wanted to make sure I put this in this video. Yeah, let's say you were tearing down a 1600 and you're going to do a stock rebuild, but you decided to, you know, up it a little bit while you had it apart. Let's say you tore it down, you found out that your crankshaft, you know, had spun a rod bearing, but the crankshaft was, the case is in good shape. You checked it, basically your backyard method of using your fingernail. If you watch some of the other engine teardowns and videos, you're gonna have to probably watch them all. You run your fingernail over the center main, and there's very little wear there. You notice it's not shiny. If you watch the 1835 teardown, towards the end when we tore down the other end, it'll show another bad center main that needs to be line bored. Those things you have to look at to make sure it doesn't need to be line bored. Let's say you just are going to just go for it and not get it line bored because you're in a place where you can't get line bore. But you decide you want to go, you would like to get a little more power out of it, and you don't have a place to get machine work done. So again, this engine here was machined to a 90.5 cylinder. So it's to fit a 90.5 cylinder, which will also fit the 92 thick wall or whatever you want it to go from there. So you're going to run stock 85.5 pistons. If you notice, this is an 85.5 piston. You see how much longer the piston skirts are? You can actually, if you're really careful, you can actually trim the skirts on these to make it more like this piston. Or I believe, I'm not sure, but I'm pretty sure that if you order the 88 thick walls, they come like this one here. But you just save your stock piston. You could order the 88 thick wall set and then put the piston next to each other. If they're like that, if you see how there's that much difference, stupid focus, I don't know why it doesn't do that. You can see the difference. If you can see that, if you put the one next to the other, then you can actually run those on the stroker crank and not have to clearance them. Sometimes if you run these are both A pistons. They have A and B. With these 74s, you run an A piston. So with the we're using the 325 rods. So, and it comes out with a really nice combination, less shim that way. So, so if you have these, you can actually clearance those pistons, the stock pistons, and make them work if you want to. I'm just telling you, you can make them like this here. So you just clearance them all the way around, and then what you do is go ahead and get yourself a gram scale from Harbor Freight Tools or something, and then make sure they're within, check the specs. I don't know exactly what they are. Make sure they're within, you know, whatever gram of each other, so that the weights are the same. So that's how you do it. So you can actually do that with a stock piston if you need to. I'm just showing you guys somewhere where you can't get machine work done. It is possible to do. Guys did that for years before they made these type of pistons. But if you get the set of 88 thick wall and you ordered, say, the heads, you know, for the 90.5 heads, the ones that are made for a 90.5 cylinder, then you can get the 88 thick walls and it'll just slide right on. So that'll make you a nice big engine. That makes an 1800 from a stock engine block. So you have the stock block right here. You know, let's say it wasn't opened up. You only had it set up for 85.5. You put the 74 in it. That gives you a nice, I think it's an 1800. It gives you, I'm not sure. You'd have to look that up. I don't remember. But it gives you from an 85.5 block opening, and a 74, you can take it up to a 88 thick wall and a 74 crank and use your stock block and not have to get machine work done, and you can still take it up to that to a bigger engine. And basically you can, that's a pretty fast engine. I mean, that's a lot of power you can get out of the stock block. So just keep that in mind. I'm just trying to show you guys the different things you can do, performance, to make your engine, you know, build what you want to build. You know, we're not building that engine right now, but because we have access to machine shop, it's just, you know, $100 or whatever, to, you know, a couple $100 in machine work to have the line bore done and those cylinders open, and, you know, we're good to go. And we know we have it all line bored right. I like to line bore just about every time, or at least have it checked by a machine shop. Okay, so let's talk about a couple of things that we're having a little bit of difficulty with. There's always some stopping points in your engine build, because you really need to make sure everything's right. With VWs, it's not just bolt it together and run it, especially when you start doing stroker stuff. So one thing you always got to check is your deck height. So we used this plate here to hold it down tight, and then we're checking our deck height. And with the shims we got in here, I think we tried to figure out, you know, we actually had the piston above the cylinder. So when we first checked our deck height, and then when we put this thing on here to make it nice and tight, we checked it again after we put some shims in, and we got, I think, I don't know what we had it, but say I think we had like 80 thousandths in shims here. And then we got our deck height. It was like, I think, say 35 or something like that. It's still too tight. Or no, it was 50. But at 50, with the CCs in the heads, which you have to CC your head on every one of these, you got to have a little CC gauge thing. You set it up, you fill it up with, all you do is you just basically, you put a little piece of plastic over the top here. You fill that up with this, with a little CC syringe. You fill it up nice and full. You check your CCs of your combustion chamber. You should check all of them if you have time. The best way to do it is check them all to make sure that your average is right. You know, you may not be able to fix it and make them better, but you know what we run into is with the VW heads, and you don't have this problem when you run the AA performance heads usually, is these chambers are so small, okay, that what we're having to do is we're having to put more shim in. Now, what happens if you have too much shim, if you've got, say, I think we're going to end up with 70 thousandths, which is kind of 20 thousandths past where I'd like to be. I like to be between 50 and 60 somewhere, okay? But if we're going to end up being at 70 thousandths, okay, 70 thousandths deck height, okay? So what's going to happen is we're going to end up with a little bit more barrel fire than I want, but it's still in that range where it's okay. When it's up to like 90 thousandths deck height, that's when I kind of go, you know, I'm kind of going, no, we got to get more CC in the combustion chamber. So one of the ways to solve that is, like I say, I like to run those AA Performance 40 intake, 35 exhaust. I like to run those heads they have. They have a bigger, more open combustion chamber. It's got a better flow to it. It has the spark plug relocated a little bit, so there's a little more room between here and the valve. If you notice, there's a little more room, and it's got the peanut style plug with the longer threads, so they don't pull the threads as often. And it also has a better port vanes. It's more opened up through here for the air to go through. So all of those things are, you know, are what everybody's looking for on these engines. So some guys actually go through and take the stock heads and they'll open up the port vanes in there and all that. And, you know, it's all these things you can do if you want to try to do it. But right now, the difficulty we're having is getting these combustion chambers to be open enough. So what we're doing is we're doing something called step cutting. This one here's already been step cut, but we're going to step cut it. We're step cutting it another, I think, 30 thousandths or something like that. So we're going to step cut these a little bit more to try and open up the combustion chamber so that we don't have too much barrel fire. So those are things, those little things you can learn, you know, over time. You may not do it right the first time, but after a little while, then you start to learn. You know, sometimes it just pays to buy those heads, you know, to just buy those heads, and because it's easier to make the combustion chamber smaller. It's not easier to make it bigger. So it becomes, you know, you can do things like maybe machine this edge down a little bit and this part down a little bit, you know, not over here really, but a little bit maybe, but not too much. But right here, you can take it, right here, you can kind of take it down, and you can open up that chamber a little bit, kind of like what they already do with the AA heads. So if you want to save yourself some hassle, sometimes it's just worth just buying them. But anyway, but since we already had these heads, we're just going to run them, and but it is taking a bit of time, and it's, you know, it's one of those things. So we had to get some more shims. We got these things here. We're at Brothers Machine Shop. Another thing you run into on a lot of these engines is, I don't know if it's the flywheel that we're getting now, or if it's the crankshafts are a little bit different, but we're finding out a lot of times that you have a problem with the shims behind it here. You know, typically you run 3 shims here, you know, to total up the distance so that you end up with a deck or a end play of I think it's 3 to 5 thousandths. Okay, an end play. So you put your stuff up. If you've seen us set the end play on some of them, you check your end play with it, and what's happening is we end up with too much. Do we have to put too much shim in here? Well, they only make so thick a shim. So what happens is you end up having to put in 4 shims. Well, we don't really want to put in 4 shims because that is, you know, it's not what they specified in Volkswagen when they built these. You know, I mean, if you had to, you could probably do it. Not what I would do normally. That's these shims right here. Okay, these little shims. So we have all these shims. We stack them up, and we make sure we end up with the right end play when we're done. So because we had to do that, and we've had this on the other engine as well, we had because we had that. What we had to do is we had to create this to be a little bit tighter. So to make it a little bit tighter between this surface and the bearing, we had to put in. We had to go ahead and have them machine this down 10 thousandths so that we didn't have to put in 4 shims. So those are the type of things when you go to put your engine together, you get to that point where you're putting the end play in there, some of the issues you might run into. The other thing that can happen is you can put it together and it's too tight. So you tighten it up and you go to check it, and there's not enough room to put in 3 shims because, you know, you're at like, you know, 15 thousandths or something like that, and it's not enough for the 3 shims to be in there. So what they'll do is they'll machine this surface down right here. So we're finding a lot more of that with the parts today. So keep that in mind. If you know that when you get to that point where you're doing your end play, you might have to send this flywheel out somewhere. You might be able to find a place locally to do that, but you might end up with that issue. So if you guys are far from someone, you might have to deal with that way. But there might be somebody who can actually cut this out. We went to Brothers Machine Shop, where we always go, because they do a great job of machining, and they machine that out for us. And I went and picked up some other things there. They also have some parts. If you're in the area and you have to go there for something, they do have those things available if you're in Ontario, California. All right, so anyway, we'll talk to you guys in the next portion here. All right, so here's where we're at now. Remember, a lot of people watch the 1600 build and go, wow, that went really fast. How come you can't do it in one video with these strokers? There's a lot more little things to do to show in these. So it does take more video time. It does take more stuff to show in here. So we're going to have to cut this one off at this point, and then we'll bring you guys back when we get in another video, when we do the cylinders and put the heads on and kind of show you what we did with those. We did get them CC'd out right. It's a little more work when you're using the stock heads. If you were using the AA Performance ones, usually it's just a little bit of machining once and you're done. You put them on. So what we had here is we ended up going to Brothers Machine Shop, had this remachined in here, did a great job. Then that was kind of the second time we got it machined once and it didn't work out. And so then we went there. I just went down there because I just knew that it was going to be right. So I went there and got this thing machined. So we had to machine this down further so that it had more in play. But we machined it a little bit too far because we gave them a first, I don't know, it's a long story. But we ended up with a little bit too far. And then so we ended up having to use a paper shim here, which to bring it back a little bit. So you can get those. So they have these at Crankshaft. If you need these, it's good to have these whenever you're doing your end plate, because you have a lot of different things that can go. Like I said, it doesn't just go on like they used to. You end up having to use those paper shims and different things more often today with a stroker engine. So because the crankshaft, and this is made in China, and it's just whatever. It just sometimes they made different places and they don't put their heads together. It doesn't go to a VW spec. It goes to their spec and then to their spec, so it's going to be a little different. So, but we got the shims figured out. We know we can stack them. You kind of have to know, what number you're going to come up with, because they only make these shims in certain thicknesses. I mean, like the thinnest you maybe find is like an 8, and then the thickest is what, about 16 or something like that? 14, 15. So maybe they may have 16s, but you have to kind of figure out, what you need to be able to make it work. So, and you need to have 3 shims on there. Sometimes, if you had to, I'm just saying, if you guys were somewhere where you didn't have any other options, you might be able to put 4 in. Not recommended, but it might work. But you might end up with a spacing issue between here and your seal. I don't know. I don't know what the problems would be with doing that. So we always stick with 3. So we kind of have to stop at this point. And so I'm just trying to give you guys an idea of the types of things you can run into when you're building one of these, just so that it's not a shock to you when it happens. And so we're about ready to, we were almost ready to put the cylinders and pistons on, but we ran into this problem here, and so we got it kind of worked out, and we're ready to, we'll have this in play done now, and then we'll finish up the motor build. So we'll have that in a second video, and we'll put the heads on, and then we'll finish it up. The other thing, again, we had to do, and I think we're missing, is, again, when you do these stroker builds and stuff like that, we're going with full flow system. So if you're going to go with a full flow system, you have to put a plug in your pump. Now, you may not be able to find one of these what are they called? There's a name for them, flush mount plugs. I forget what they're called, but they have a specific name. And you might not be able to find one of those. And I don't like to use the brass ones because sometimes they get locked in there and you can't get them back out. I'm not as worried about that on the pump as I am if we did one on the engine. So on this one, we may just put one in the pump, a brass one, and that's it, instead of putting one in the pump and one in the engine. You can do either way. It all depends on how you want to do it. But that's another thing we ran into. So these type of things can, take a lot of time. So you got to tap this, put your other thing in, put your plug in there, so that your oil, this is your actual pressure side of your pump. So, it's pressure side of the pump. So it will return in through the fitting that you're going to put over here. I'm just trying to show you guys where it is. Okay, so it'll return in through there, so it won't want to pump oil in both places at the same time. Okay, so ramp up your comments, put them down, and let's hope, and some of you guys who watch the videos, I appreciate, you know, you guys who really know stuff, and I appreciate the fact that you guys answer some of each other's comments. So if somebody makes a comment and I don't get back to them, feel free, you guys who are experts and or people who have knowledge in the Volkswagen thing, make those replies to them, help those guys out, because this is really what this is all about. This is all to help everybody be able to learn how to do their own build. Because some of these guys, you know, some of the guys on these videos watching this stuff are in places they do not have access to, you know, a shop that they can call or a person they can get advice from. So you guys can help each other, you know, as a community, you know, learn how to fix your problems and learn how to get yourself through it. I saw that in the last video, and I really appreciate when you guys do that, because it really does help out. Because it gives us people a second opinion. Even if I get back to them, I may not have the best answer. Maybe somebody else does. So feel free to do that. And I'll talk to you guys in the next video. Please like, share, and subscribe, and we'll see you in the next one.